Hello everyone, welcome to my channel. In this video, I am providing you the week 2 solution of our NPTEL course C Programming and Assembly Language. In this video, I am going to provide you the practice assignment solution, and in the next video, I will provide you the quiz 2, that is assignment 2 solutions. So let's start. The first question is, that is, the inline assembly refers to the interspacing a C program with a block of assembly code to carry out a particular operation. So here we are using this inline assembly functions that is used for integrating our C programming code into our assembly code. So that is, the option is true. So the answer for the question is true. In the second code, in the following C code, that is statement 1 does not translate to any assembly statement. The answer for this question is true, because the first statement is, that is, hash define square of x, x into x. This is a preprocessor directives. And for the preprocessor directives, we cannot write a assembly statement. Whenever we are doing a combination of this C program and the assembly code, that is a mixed mode programming, that time we can say that it is called as an inline assembly code. And there are some programming statements that are written in C that we can change into our assembly code, and we are writing it into dash dash ASM directory. But here we cannot write our preprocessor directory into our assembly language code. That's why this statement is true, that is statement 1 does not translate to any assembly statement. The option for this question is true. Now the third one is, third, fourth and fifth question, the code snippet is given, and based on the execution of all this line of code, that is 13 statement will be executed, and after that we have to find out what are the values of our EAX, then our how many times we are executing this label loop, and what is the value of our Z after execution of all these statements. So now we will see how this code will be executed and what are the values of this question number 3, 4 and 5. So in this code snippet, the first statement is, that is, the multiplication function is given and our value of our x is equal to 3 and y is equal to 4. That is given in that program. So now the value of our z is equal to 0, and here we have started to write our assembly code. So this code is integrated within our C programming code, that is called as an inline code. So the first statement is XOR EAX and EAX. So whenever we are performing the XOR operation with the same variable, then value of our EAX will be 0. Now the next statement is move ECX, then Z. So here we are taking this value, that is move ECX, and we have to find out what will be the value of our ECX. So I'm writing here, the contents of our ECX will be copied from the value of our Y. So ECX will be copied from the Y value. So our ECX will be the contents of 4. So the value of Y will be copied into the register ECX. Now we have taken this ECX as a counter. So this is called as a counter, and this counter will be used in that particular label. So this group of label statement will be executed multiple times till we want. So here what is given in that particular label, the first statement in the label is, that is add EAX comma X. So here we are adding this EAX is equal to EAX plus X. So what is the value of our EAX? It is 0. So 0 plus what will be the content of X? That is 3. So 0 plus 3, we get the value 3. Now we have to decrement this counter. So whenever we are decrementing this counter, it will become, first of all it is 4, and after decrementation it will become 3. So here we have to check the condition in the JNZ instruction, that is jump not 0. Then we will go to the label. And here we are taking this counter register and we are checking if counter is not equal to 0, then we will go to the particular label and our label is LBL. So here 3 is not equal to 0, our condition is true. Then again we will redirect to the particular label, that is LBL. So again we have to execute this statement, that is add EAX X and decrement ECX in the second pass. This is the first pass, and in the second pass, what we are doing, we are executing this whole statement again. So in the second pass, if we are executing this one, then we get our add EAX comma X. So EAX is equal to EAX plus X. So what is the previous value of our EAX statement? That is the value 3. So I'm taking this value 3 and our value of X is equal to 3. So 3 plus 3 is equal to 6. And again we have to decrement this ECX as per our code. So here the statement is decrement ECX. So whenever we are decrementing the value of ECX, we have to check first of all what is the previous value. So after decrementation, our ECX will be 2 and 2 is not equal to 0. Again we will go to the label and we will execute the third pass. In the third pass, again we will redirect to the label and again we are adding this EAX comma X. So EAX is equal to EAX plus X. So what is the previous value of our EAX? That is 6. So I am adding here 6 plus 3 is equal to 9. Now again I have to decrement this ECX register. So previously the value of ECX is 2. So after decrementation it will become 1. So again 1 is not equal to 0. Then again we will go to the label. So in the fourth pass, again we are decrementing and adding our EAX value. So first of all I am writing here label, then add EAX comma X. So again we have to perform this operation like EAX is equal to EAX plus X. And the value is 9 plus we are adding this value of X. And we will get the answer, that is 12. The contents of our EX will be 12 and we are decrementing here our ECX value. So our counter will be, previously it is 1 and after decrementation it will become 0. So 0 not equal to 0, this condition is false. Then we will not redirect to the particular label again. We will simply go to the next statement of our code. So here what will happen? So whenever we are executing this code, we have to check first of all what will be the contents of your execution. So previous contents of our EAX will be 12, that we have to copy into our Z variable. So here you can check what is the next statement after this JNZ label, that is move Z comma EAX. So whenever you are executing this statement, your value of Z will be 12. Now what is given in the question? You have to find out what is the value in the register EAX after execution of statement 5. So here is your statement 5 and you have to find out what is the value of EAX after execution of the statement. So after execution of the statement, the value of EAX will be 0. So for question number 3, the answer is 0. Now, the question number 4 is, how many times does the statement 7 will be executed in the above code? So, this is your statement 7 and this is the label and this label will be executed till our counter value becomes not 0. So, So you can check here, this is your label, and this label will be executed in our program till our counter value not equal to 0. And we have set our counter to our value y, and our counter value is 4 because we are copying the contents of y into our counter. So this loop will be, this label will be executed till 4 times. So the answer for this question is 4, because 4 times we are executing this label till our counter is not equal to 0, and it will be equal to 0 after execution all this passes. Now the next question is, what is the value stored in the variable z after execution of above code? Means when the whole code will be executed, then which value will be written by the z variable? So the value of our z is 12. So I am writing here the answer for this question is 12. So in this way we can solve this question and we can find out the value of EAX, then our counter value as well as our value of our Z.